the Astronomical Society Certificate Program, Beyond Polaris. This program will be about binary stars and star clusters. Binary stars. Binary stars are important to astronomers as they allow the masses of stars to be determined. A binary system is simply one in which two stars orbit around a common center of mass. That is, they are gravitationally bound to each other. Most stars are in binary systems. Perhaps up to 85% of stars are in binary systems, with some in triple or even higher multiple systems. The orbital periods and distances of binaries vary enormously. Some systems are so close that the surfaces of the stars are practically touching and can exchange material. Others may be separated by a few thousand astronomical units and have orbital periods of hundreds of years. Orbit of stars in a binary system. This diagram shows how the two stars in a binary system each have an elliptical orbit. It can be almost circular in some cases. They share a common focus, which is the center of mass, or barycenter of the system, and orbit around this point. The radius vector joining the two stars always cuts through the barycenter. Binary systems may have highly elliptical orbits as shown above. In these cases, the eccentricity, E, is closer to 1. If E is close to 0, the orbits will be more circular. Star clusters. Billions of trillions of stars illuminate the galaxies of our universe. Each brilliant ball of hydrogen and helium is born within a cloud of gas and dust called a nebula. Deep within these clouds, knots can form, pulling in gas and dust until they become massive enough to collapse under their own gravitational attraction. During the collapse, the center of the knot heats up to form a hot core called a protostar. The protostar continues to gather dust and gas, taking millions of years to mature into an adult star like our Sun. All the while, heat energy from the core provides enough outward pressure to keep the star from collapsing under the inward gravitational pressure of its own mass. In the hot core, thousands of quintillions of nuclear fusion reactions convert hydrogen atoms to helium atoms each second, giving off massive quantities of energy that make the star shine brightly. Stars often form in groups or clusters from the same nebulae. Over time, the leftover dust and gas around a star blow away or form into other cosmic bodies like planets, asteroids, and comets. Gravity then pulls the young stars together, and they begin to orbit each other. Star clusters can contain as few as 10 stars or as many as millions of stars. There are two main types of star clusters: open clusters and globular clusters. Open clusters. Open clusters contain between a few dozen and a few thousand stars, all formed from the same initial cloud of gas and dust. The density of stars is low enough in these clusters that individual stars are visible with a telescope, or sometimes with the unaided eye, giving them an open appearance. Most open clusters reside in the arms of spiral galaxies, and their stars are usually relatively young. Their shape is more irregular than spherical, with large amounts of gas between the stars. 4 open clusters have been known from earliest times: the Pleiades and the Hyades in the constellation Taurus, the Beehive cluster in the constellation Cancer, and Coma Berenices. Globular clusters. Globular clusters are much larger and denser than open clusters, containing several thousand to millions of stars, all formed from a shared nebula. Unlike open clusters, the density of stars at their centers is so high that individual stars are hard to discern, even with powerful telescopes. Globular clusters lie on the outskirts of galaxies, and their stars are older than those in open clusters. Globular clusters contain some of the oldest known stars in a galaxy. Old stars tend to have a reddish glow, so globular clusters generally appear redder than open clusters. Messier 15, or M15, also designated NGC 7078 and known as the Great Pegasus Cluster, is a globular cluster in the constellation Pegasus.